Okay, now we're going to apply what we've been learning in 4, 2, and 3 to a real life situation. Right? And we have this this graph here that shows a initial value of a gift card, and then how much the value has changed over time with this function. How convenient. All right, and A is the amount of dollars that's left on the gift card, and this is the amount of dollars left on the gift card, and this is, what would you believe it, time, right? I think, and it's still left after purchasing cups of coffee. Oh wait, no, this is in dollars that is still left after purchasing cups of coffee, and this is the number of cups of coffee. Okay, so it's really showing you, dollars remaining versus cups of coffee purchased. That's what this is showing you. Okay, dollars remaining versus cups purchased. It looks like she's buying the same thing every day, because it looks like it's about $2.75 a pop. Not a pop, like a coffee. She's not drinking soda. She's drinking. Anyway, so what can we pick out from this thing? Well, what is our variable? We know that y equals mx plus b, and this can be replaced by f sub x, or in this case, a sub c. Right? The a is the amount of money, right? And it's a function of c. It's a function of c, which is the number of cups, right? So what in here looks like the number of cups? Well, a sub c, this is our slope. This is the only thing that has a variable in it, right? So our slope is 2.75 cups, right? So that's our slope. This is our m sub x. And what's the y-intercept? Well, the y-intercept started at 20. Look at that. It started at $20, most likely. $20. That's how much was loaded up on the card at first. Okay, and then what's the x-intercept? Well, you kind of have to do the math for this one, because it looks like it's between 7 and 8, but you have to set your a sub c equal to 0, right? To figure out how many cups of coffee is gonna bottom out at, right? But you can also see it shows you right here what this is gonna be. Right, so if you wanted to calculate it, you would calculate it, but you can also see that it's going to be x-intercept is going to be 7.27 repeating, right? And if you want to convert that to a fraction, you just do 27 divided by 99, and it's 3/11ths, right? It's going to be 3/11ths. X-intercept is 0, 3/11ths. That's the y-intercept. We need 3/11ths, 3/11ths, 0. Right. So that's the 7 and 3/11ths. Excuse me. 7 and 3/11ths, 0. Okay, that's the x-intercept. All right. So that's what we're looking at right here. Okay, it tells us right here what the x-intercept is, or in this case the c-intercept. Okay, the c-intercept, and the y-intercept is the a sub c intercept. A sub c intercept. Okay, the a sub c, because A is our money is a function, money remaining is a function of the number of cups we buy. All right, so what's the domain? Well, our domain is here to here, right? The minimum, in this case, it seems a little bit counterintuitive, but the minimum is 0 to 7.2, right? So it's going to be 0, it can be included in 0, and then C's in the middle, and then 7 3/11, right? 72, 7 divided by 99 is 3/11, okay? So you write your domain, like we'll say our domain equals all values of C such that 0 is greater than or equal to C. That's the number of coffee cups we bought. Now I can't really buy 3/11 of a cup of coffee, right? I can't really buy 3/11 of a cup of coffee. That's what we're talking about, viable down here in a real world context, right? So, as a viable domain, I'm gonna truncate that 3/11 off, okay? And I'm gonna say 3 to 7, and I'm gonna say greater than or equal to 7, and is an element, and I'm gonna say instead of all real numbers, I'm gonna use integers, which is Z. Integers, that's all numbers, not including fractions. Okay. Oh wait, no, I don't want to do that. Oh yeah, I do want to do that. For my C, I want to do that because I don't want to use the set to 7 there. Okay. So, so that's good there. Now my range, I do want to use any number, right? So my range is going to be R equals, we'll call it A. Range equals a set. So what can it be? Well, it's A such that it started at it's going to be less than 20, but it can't be anything less than 0. It can't be more than 20 or less than 0. Right? So it's going to be 20, between 20 and 0. Right? So it's going to be 0 or 20. I'll write it from 0 to 20, I guess. 0 greater than or equal to 20, or my A, and then equal to 20, all numbers. I don't want to be all real numbers. Yeah, that's fine. I can use all real numbers because I identify greater than 0. And then all real numbers. All right, so that's my domain, and that's my range. And we already talked about viable, right? It's viable as a key feature is viable if it's feasible in a real world context. And like I said, I can't buy 0.27, right? And that's if it's repeating like this, this was 7.27 repeating, right? If it's 2 digits repeating, you take that 27 and put it over 99, right? And that ended up reducing to 3/11, right? If it's 1 number repeating, you put it over 9, right? If it's 3 digits repeating, you put it over 999 if you forgot how to do all that stuff, right? But it's a rational number, right? But it's not rational to say I can buy 3, 11ths of a cup of coffee. That doesn't make any sense, right? So that's why I threw that z in there, right? Because my z values are any